Hi guys, good evening. Am I audible and visible to everybody? Hi, Uruz. Hello, Sashikumar. Guys, first let me know if you can see me or hear me in the chat box. Also, I can't see your faces. Make sure that you are sitting in the class by turning on your camera. All right, so I am audible and visible. That's great. So, how are you guys and how was your day? Hi, Alia. Hello. How are you? How's life going on? Any issue, anything that you're facing problem in? Hmm? Hi, Subiksha. Hello. Good evening. Guys, why your cameras are not on? Please turn on your cameras, everybody. So, this is lecture number 2 of Haloalkanes and Haloarenes. I'm sure that you guys did the revision of whatever topics we covered in the previous session. How many of you guys, how many of you did the revision of previous class topics? Hi Asif, good evening. Just write me in the chat box, all of you. Guys, it's organic and revision is very important. Otherwise, we'll forget the reactions and all. So please make it a rule that you every time before the class, just revise the topics, go through those topics once. That way it will help you a lot, and make it a rule first of all and stick to it. That's wonderful. Asif, Uruz, Suviksha, Jessica. So do you guys have any doubt in any of the topic? Any doubt in any of the topic? So first session was very easy, no? It was very basic. So I don't think you have. In case you have any, so please let me. Till now, no doubts. That's great. So today, what we are gonna do? We are gonna discuss about the preparation of haloalkanes and haloarenes, and then we will talk about physical properties of haloalkanes and haloarenes. Okay? So what we did in the previous class? In the previous class, we discussed about what we first understood. That first was the introduction. Second one was then we came to nomenclature. Nomenclature, we discussed how to write the names of the compounds. Also, we studied that how we classify haloalkanes and haloarenes based on the hybridization, based on number of carbon atoms, hybridization of carbon atom to which your halogen is attached. That's what we discussed. And you guys asked questions as well related to nomenclature. So I'm sure that nomenclature is now clear to you. Hi, Reshmi. Good evening, beta. See, I have noticed that like students are coming in the class. Uh, I mean 10% of the students or 15% of the students are the ones who are just wishing in the chat box. Don't you think that it like these are? I'm not saying that come in the class and wish me. No, I'm not talking about that. But it feels great at all of you if you all are coming in the class saying yes, ma'am, good evening, how are you? So I think that way I'll also feel good, है ना? I'll also feel connected. So please don't feel shy and try to connect with your teachers. Okay? Thank you, Fazila, for turning on the camera. Others also, please turn on your camera. Good evening to all my lovely students who just joined the session, and try to join the session on time. That's also again my request. Okay? Chalo. So with this note, let's get started with the session. So how's the Josh, all of you, for today's class? As I told you, we are gonna discuss about, first we will talk about preparation. In any chapter, first we discussed about nomenclature, we'll talk about preparation, then we'll come to the properties, physical properties and chemical properties. In today's class, we will be able to finish only the physical properties. Chemical properties are lengthy, so those will be covered in the next session. Okay? Physical, chemical properties, and then we'll come to the uses. Right? Chalo. So how's the Josh, everybody, for today's class? Let me know in the chat box, guys. Or for organic, you guys were very excited from the beginning, no? Ma'am, please do organic chapters. And now we are those like studying organic. So Josh should be really, really high. All right. So great. So now let's talk about the preparation. So we will be talking about preparation of haloalkanes first of all. So write down the heading preparation of haloalkanes. And in haloalkanes, first we will be preparing our haloalkanes from alcohols. The first method is from alcohols. Okay. And guys, just try to learn the reactions in class itself. And if you will revise them after the class just 2 to 3 times, they will fix into your mind. Okay. So the first one is first one is preparation of alkynes from alcohol. We'll be preparing from alkanes as well, alkenes as well, alkyl halides as well. So first is from alcohol. So when alcohols they are treated with, this is your alcohol. When we treat any alcohol with HCl in the presence of ZnCl2, ZnCl2, that is anhydrous ZnCl2, anhydrous ZnCl2, then what will happen? There would be formation of Leucas reagent. Yes, it is. And this process is called Groove's process. So I'm glad that you already know, because you also have studied these chapters in your school. So when we treat alcohol with HCl in the presence of anhydrous ZnCl2, let me write it clearly. Just a moment. Anhydrous ZnCl2. So what will happen? There would be formation of chloroalkane. And how chloroalkane will form? Hydrogen from here, OH from here, that is gonna remove. And what will happen? Your chlorine will attach with the R group and will form your chloroalkane, RCl plus water. I'll tell you the function of anhydrous ZnCl2. Also, one more thing I want to convey is that, guys, this is not the mechanism of the reaction, and you don't have to study the mechanism of all the reactions. Whatever mechanisms are there in your syllabus, I'll explain those mechanisms to you. If we will study the mechanisms of all the reactions, it will take at least 4 years to study organic chemistry. So so we are not going to do mechanisms of all the reactions. They are not there in our syllabus. Whatever is there in our syllabus, I'll explain that mechanism. Okay? I'll give you whatever reasoning is there. I'll explain you each and everything, but not gonna study mechanism of each and every reaction. Again, here I've explained that water will remove. This is not a mechanism, and you cannot remove water like that. But this is just a way to explain you that how products are forming. Okay? All right. So this is your primary alcohol. You are treating it with HCl in the presence of anhydrous ZnCl2. Then RCl is forming, haloalkane is forming. That's what we wanted to prepare. Now this process of treating your primary or secondary alcohol with HCl in the presence of anhydrous ZnCl2 to form chloroalkane, this process is called Groove's process. Groove's process, Grooves, Groove's process. Okay, so sometimes in the in your exams, I'm talking about your board exams. So in your school exams or board exams, they ask questions related to name reactions. One of the name reactions. Okay. Now what will happen if you will take secondary alcohol? So let's suppose this is a carbon to which your OH is attached. Now in case of secondary, this carbon must be linked with 2 other carbon atoms. So this is my secondary alcohol. Third here is hydrogen. This is 2-degree alcohol. So you are treating this 2-degree alcohol with HCl in the presence of anhydrous ZnCl2. Anhydrous ZnCl2. So what is going to happen? Again, your water will remove and your chlorine is going to attach with the carbon atom to form chloroalkane. Right? CH3, 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 and then here we have Cl along with the removal of water. Right? This is for your 2-degree alcohol. Now let's talk about 3-degree alcohol. I'm sure you have noted it down in your copies. I can move towards the next slide. Done. Please try to note down everything with me, because that way it will save your time and I'll be having more time to explain you. Okay? So now let's talk about 3-degree alcohol. In case of 3-degree alcohol, this is your CH3, CH3 and CH3. This carbon to which your OH group is attached is linked with 3 other carbon atoms. So of course it is 3-degree alcohol. and you are treating it with HCl. Now here, when when the alcohol is 3-degree alcohol, you don't need anhydrous ZnCl2. Here, presence of ZnCl2 is not required. I'll give you the reason that why the presence of anhydrous ZnCl2 is not required. So I'm not writing it. The reaction will take place simply by mixing on at room temperature. So what will happen? Your water will remove H from here, OH from here, water will remove, and what you will get is CH3, 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 and here we have OH along with the, sorry, not OH, Cl, along with the removal of water. But the point is that why we don't need anhydrous ZnCl2 when the alcohol is 3-degree alcohol. So anhydrous ZnCl2 is a Lewis acid. ZnCl2, it is a Lewis acid. It acts as a Lewis acid, and you know that Lewis acids are electron deficient species. They have tendency to accept the electron pair. So when they act on we, let's suppose I'm taking the case of primary alcohol. This is your primary alcohol, ROH. In alcohol, oxygen has lone pair. Oxygen has 6 electrons in its valence shell, but out of the 6, it has made 2 bonds with 2 electrons, 4 electrons are remaining, so it has 2 lone pairs. And when you are taking ZnCl2, of course ZnCl2 is a Lewis acid. So what happens whenever in any organic reaction there is a electron with speciation, there is a Lewis acid, so it is gonna donate the electron pair to this ZnCl2. So what will happen? It will form RO. This is your hydrogen, because oxygen has donated its lone pair, so it would get positive charge. And then we have ZnCl2. ZnCl2 will link. Now, oxygen is the second most electronegative element. Who is the most electronegative element in the complete periodic table? Which element is most electronegative? That is fluorine, and oxygen is second most electronegative element in the periodic table. Do you think that it can tolerate this positive charge? When it has this habit of attracting electron, gaining electron, do you think that it can tolerate this positive charge now? एक अमीर को गरीब बना दिया आपने, तो वो स्टेबल हो जाएगा क्या? Tell me, all of you. You have taken its electrons and now it has positive charge, so it is unstable. Oxygen can't, being an electronegative element, it can't tolerate positive charge. So what is going to happen? वही ऑक्सीजन का दिल तोड़ देगा, नहीं ऑक्सीजन का नहीं तोड़ेगा. So what is going to happen over here? This bond, the carbon of alkyl group and this oxygen bond, it is gonna break in such a way that the shared pair of electrons will transfer towards oxygen. So that way oxygen will gain the electron pair back and it will again be neutral, having its lone pair. So resulting into the formation of a carbocation. R will be having positive charge and this ZnCl2OH that will form. Okay. So what is happening over here? Like in this mechanism, you have seen that ZnCl2 is helping in the cleavage of bond between cleavage of this carbon and oxygen bond, right? Now in this, on this carbocation, Cl minus will come and will attack, resulting into the formation of RCl. So what is happening over here? What is the function of ZnCl2 and hydrous ZnCl2? That it helps in the cleavage of this carbon oxygen bond of alcohol. Is this clear, all of you? Now, why we don't need it in tertiary alcohol, that I will explain. That's remaining. But tell me if it is clear or not. So ZnCl2, what is the function of ZnCl2? That it helps in the cleavage of, it helps in the cleavage of carbon oxygen bond of alcohol. Okay. Array, is this clear? Boss, everybody, is this clear to everybody? Okay. Now let's talk about why we don't need it in case of 3-degree alcohol. Let's talk about it. Noted?
Ma'am, can you go to the previous slide, please?
This one.
Yes, ma'am. Ma'am, for the secondary alcohol, will it turn to tertiary degree or only secondary alcohol? Because you wrote it as tertiary alcohol from secondary alcohol.
What? I'm not understanding.
Ma'am, from secondary alcohol, anhydrous
Oh,
ZnCl2, will it
oh,
give?
okay. Sorry, sorry, sorry. Here hydrogen should come. I'm so sorry. My mistake. I'm accepting. Okay? Clear? So it is hydrogen. Here it was by mistake. Noted. Chalo. So now let's talk about 3 degree. 3 degree alcohol. Why the presence of ZnCl2 is not required in case of 3 degree. So because in case of 3 degree alcohol, we have 3 alkyl groups attached. See, oxygen has lone pair already, 2 lone pairs. And with carbon, we have 3 alkyl groups attached. And you know that alkyl groups are electron donating because of its hyperconjugation, because of inductive effect. All the alkyl groups, they are electron donating, right? That's what you guys must have studied in class 11th. So here we have 3 alkyl groups. They are donating the electron to this carbon atom, because of which there would be an increased electron density on this carbon atom. There would be a great repulsion between already present lone pair of oxygen and increased electron density on carbon, because of which the bond will break on its own and carbocation will form on its own. That is why the presence of ZnCl2 is not required. Okay? Because of, again I'm repeating, because in case of 3 degree alcohol, 3 degree alcohol, 3 alkyl groups are present, and 3 alkyl groups, they will show plus I effect, donating the electrons to this carbon atom, because of which the electron density on this carbon atom would increase, and then there would be a repulsion. Like here the repulsion would be maximum as compared to 2 degree and 3 degree. In 2 degree and 3 degree also the inductive effect was there, but here it is maximum. So here repulsion would be more and the bond will break on its own. That's why the presence of ZnCl2 is not required. So can we say that a 3 degree alcohols, they are most reactive? So if I talk about reactivity of alcohol. So if I talk about reactivity of alcohols, 3 degree alcohols are most reactive. Alcohols are most reactive. Then we have 2 degree. Then we have 3 degree. अरे क्या वो कर रहे हो मैं 3 degree नहीं 1 degree. This is the order of reactivity of alcohols. And now let's talk about hydrogen halides. So here we carried out the addition of HCl. Hydrogen has, like, hydrogen can combine with any of the halogen. So it, like, for all the hydrogen halides I'm writing here, HF, HCl, HBr and HI. Right, beta? So these other, like, other than HCl, we can also carry out the addition of HBr, HI or HF. So if I'll talk about their reactivity order, here the reactivity of HI would be maximum and HF would be minimum. Can anyone tell me why? Because because here the bond between hydrogen and iodine would be weakest bond, because the size of iodine is very big and hydrogen is very small in size. So don't you think here the bond would be weakest and it can easily give I minus ion, because it can easily give I minus ion. So it can easily attack onto the attach with the carbocation of alkyl group and can form alkyl halide. So here this is the order of reactivity of hydrogen halides. This is the order of reactivity of hydrogen halides. Is that clear, boss? So what I told you in the first preparation was from alcohol. Like there are many more points in it, but we started about Gru's process, wherein we were carrying out the addition of HCl to alcohol in the presence of anhydrous ZnCl2. Then it was forming chloroalkane. What if you have to make Bromoalkane, what if you have to make iodoalkane? So in that case, what will you do? That we have to discuss. First of all, tell me if it is clear or not. Everybody, quickly write CC in the chat box. Chalo. So now let's move ahead and let's talk about what bromoalkanes. What if you have to prepare bromoalkanes? So if you have to prepare bromoalkanes, you'll be carrying out the reaction of alcohol with HBr, and the reaction is carried out in the presence of H2SO4. Here we carry out refluxing. You know what is refluxing? You know what is refluxing? I added one slide here just to, nobody is going to ask you what is a reflux, but this term is going to be used in other reactions as well. So refluxing is like it is used in organic, like for the preparation of organic compounds. When I was in college, we used to prepare organic compounds by treating the reaction mixture for long hours, like 25 hours, 26 hours, like that. So what we used to do, we used to take a round bottom flask and the reaction mixture, and then we used to keep it in a like in a beaker where water was there, and we used to heat it indirectly. So in refluxing, what is there that you have taken your reaction mixture, and now this condenser tube is attached, and in this condenser tube water is coming in and going out. What there is a circulation of water. I'm sure you might have seen this distillation process. Have you seen distillation? So in distillation also we use a condenser tube wherein water is coming and water is circulating around so that the vapors can cool down. So this process, when we heat the reaction mixture in such a way that we do refluxing, and this process is used for preparing organic compounds. So what is happening, whatever is you are heating, that they will evaporate, so they will condense over here and they will come back. So this is how we carry out the preparation. So refluxing is the process of heating a liquid in a flask provided with a condenser, and the vapors of the liquid, they will rise up, condense there, and they will come back. So this process is carried out for long hours, and it is different for different reactions. Okay. So I'm sure the meaning of the word reflux is clear to you. So what we will do, we'll take alcohol, HBr, H2SO4, we will add and we'll carry out this refluxing. Simply, it's not a simple heating, it's a process I have explained. So what will happen here, your water will remove, H2O will remove, and HBr, the RBr will form. RBr along with the removal of water. Okay. Now, what if you want to prepare iodoalkane? So, if you want to prepare iodoalkane, you can treat your alcohol with Ki, simply reflux it, and then you will get your Ri, you will get Ri and KOH, alkyl iodide and potassium hydroxide. Okay. All right. And yes, why we are not carrying out the reaction with HF? Because HF is least reactive. The bond between hydrogen and fluorine is quite strong, which is difficult to break. That's why F minus cannot leave easily. Okay. So that was all about addition of hydrogen halides on alcohols. We carried out the addition of hydrogen halides on alcohols. Now our next reactions are like when we treat alcohol with PCl5, with PCl3 or thionyl chloride, that's our next reaction. Done. So this was under the category of addition of hydrogen halides. From alcohols, in alcohols we have subcategories. One was addition of hydrogen halides. Let me write here, you can mark it as A, addition of hydrogen halides. Okay? All right, beta? Clear? बोलते बहुत कम है. And I'm someone who need assurance at every step. Yes, ma'am. Yes, ma'am. Make it a habit. Okay. Chalo. So now let's talk about from alcohols. In alcohols, we have second category. What is the second category? Second category is addition of reaction of alcohol with phosphorus halides. Write down B. Reaction of alcohols with phosphorus halides. ठीक है? How many phosphorus halides do you guys know? Phosphorus halides.
PCl3 and PCl5.
Very good. Yes, बिल्कुल Aryan. This one beta.
Yes, ma'am. Would the reaction be the same if we just use HI?
What?
Would the reaction still be same? Like, would it still work if we use HI?
HI, yes. Again, the reaction would be same, but in that case, water will remain. You can
Okay.
also use HI here in place of KI.
Yes.
ठीक है? चलो. So, yes. So now let's talk about So we have to carry out the reaction of alcohol with your PCl5, alcohol with your PCl3. So please keep in mind, everybody. First of all, we are studying the preparation of haloalkanes. So RCl will form over here. RCl. You can both the reactions. Please keep in mind that in the reaction of PCl3, from Cl3 you have to keep in mind that H3PO3 will form over here. PCl3, so with 3, you can keep in mind H3PO3 will form, right? And in the reaction, when we carry out the reaction of alcohol with PCl5, here POCl3 will form POCl3. So out of 5 chlorine atoms, 3 are here, 1 is here, and 1 would be HCl. HCl. So in the reaction of alcohol with PCl3, H3PO3 will form, and in the reaction of alcohol with PCl5, POCl3 will form and HCl will form. Now let's check if the reaction is balanced. Second one is not balanced, so we'll multiply here by 3, here by 3, and now my reaction is balanced. Okay? And the C part is reaction with the thionyl chloride. Reaction with thionyl chloride, and thionyl chloride is SOCl2. Thionyl chloride. That is reaction with SOCl2. Okay. So here you are going to treat your alcohol with SOCl2, which is thionyl chloride. Then of course it is going to give RCl. What would be the side products? RCl, then HCl and SO2. SO2 and HCl. And HCl will remove here in the form of a gas. So this method is considered as best method for the preparation of haloalkanes, because the products, the byproducts so formed here, they are escaping gases. So you don't need to perform any purification technique. So this method, reaction with thionyl chloride, is considered as best method for the preparation of haloalkanes, because the byproducts formed here, they are escaping gases, so they will escape out, and what will remain is your haloalkane in its pure form. Is this clear, beta? Best method for preparation. Preparation, because byproducts are escaping gases. Cool. Escaping gases. So we did the from alcohol we have understood. Reaction mixture to the pure product. Very good. आसिफ को तो सारी reactions ready हुई हैं, है ना? No ready ना. अरे अच्छी बात है. It's a compliment. Beta noted. Then let's move towards the next one. So we have prepared our haloalkane from alcohol. Now we will talk about preparation from hydrocarbons. let's talk about the second one, that is from hydrocarbons. And in hydrocarbons, we'll first prepare from alkenes. From alkenes, you can write down from hydrocarbons, and the first we have alkenes, from alkenes. So let's take the simplest alkene. You have ethene. Simplest alkene is ethene. This is your ethene beta. So you have to carry out the addition of hydrogen halides, and hydrogen halides you already know. HF, HBr, HCl, HI, they all are hydrogen halides. So when you will carry out the addition of, let's suppose you are carrying out the addition of HCl on this alkene. Now guys, this alkene is a symmetrical alkene. There are two cases in this. One is symmetrical alkene, another is unsymmetrical alkene. If I talk about this case, this is symmetrical alkene. Why it is symmetrical? Because the two carbon atom which are making double bonds, they have two hydrogen atoms attached to them. Both the sides we have equal number of hydrogen atoms. So this is an example of symmetrical alkene. Symmetrical alkene. Okay. So you are carrying out the addition of HCl. So what is going to happen? That in chlorine, here in HCl, H is positive and Cl is minus. Now chlorine can attach here or here. If it can attach anywhere, because this is symmetrical. So here it is gonna give similar product. If it will attach here or here, it will give same product. So yes, on addition, let's suppose your hydrogen is getting added here and Cl here. So what is gonna happen? It will form CH3 and CH2Cl, right beta? So how it is happening? Because there are pi electrons and pi electrons, they are loosely bounded. If they are loosely bounded, let's suppose your electron density is shifting here, so this will get negative. In this case, it is shifting this side because I have attached hydrogen here. So if they are shifting here, so this would get negative. So hydrogen will attach here, and to this positive Cl minus will attach, and you will get your haloalkane. In case of symmetrical alkene, what I want to say is that you can attach your negative part anywhere, not anywhere, like at any of the carbon which are making double bond. Okay, getting my point? Let me give you one more example of symmetrical alkene. Let's suppose you have CH double bond CH, CH3, CH3. Is this symmetrical alkene beta? Is this symmetrical? Quickly, please be quick. Yes, it is symmetrical because the carbon atoms which are making double bonds, they have equal number of hydrogen atoms. So this is again an example of symmetrical alkene, and here the negative part, symmetrical alkene, negative part can go anywhere. It can go here or here, both of them, like you'll get the same product. So what you can make the product as CH3 CH2 single bond, hydrogen will attach here, and here Cl will attach, double will convert to single bond. So you are getting this product, that is 2-chlorobutane. Now what if your alkene is unsymmetrical? So let's take the case of unsymmetrical alkene. Let's take propane. You have CH3, CH double bond, CH2. Is this unsymmetrical? Yes, it is unsymmetrical. Why it is unsymmetrical? Because the carbon atoms which are making the double bond, they have unequal number of hydrogen atoms. Okay. So now when you will carry out the addition of HCl, the point is Cl can, this is your positive and this is your negative. Cl can attach here or here, in both the cases it will give different product. Now the point is to find out which product would be the major product. So I am sure, what about two double bonds? So it is gonna attach at both of them. And you will get that di substituted product. Okay. So so coming back to here, I'm sure you guys have heard about Markovnikov's rule in your class 11th. Markovnikov's rule, which says that negative part of the adding molecule goes to the carbon which has less number of hydrogen atoms. Yes, negative part of the adding molecule goes to the carbon which have less number of hydrogen atom. If I look at these two carbon atoms, here it is one hydrogen atom, here we have two. So the negative part should attach here, and that will give the major product. And you have to make only the major product, not the minor one. So here you have CH3, CH, and here Cl, and this double will convert to single bond, and hydrogen will attach here. So you'll get 2 chloropropane. This would be your major product. I'm sure everybody is aware about Markovnikov's rule. Here you have to follow Markovnikov's rule. Let me write here Markovnikov's rule, which says that negative part of adding molecule goes to the carbon which has less number of hydrogen atoms. Is this clear, boss? So that is how you can prepare your haloalkanes from alkanes by carrying out the addition of hydrogen halide. Okay. But let's suppose I have a doubt in Markovnikov's rule. Does that carbon gets partial negative charge due to plus I effect? Partial negative charge? No. I'm sure you have studied its mechanism in class 11. The mechanism was also there in the syllabus. The carbocation is more stable. In this case, the carbocation would be more stable because of a higher plus I effect. But we have to explain that with the help of mechanism. Okay? So plus I effect would be applicable because in this case, when we study the mechanism of this case, so we get carbocation will form over there, and that carbocation is more stable in case of the carbon which is having less number of hydrogen atoms. So your answer is partially correct. Okay? Yes. So I'm sure Markovnikov's rule is clear. Now let's talk about anti-Markovnikov's rule. Anti, it is anti of whatever Markovnikov said. So Markovnikov said that negative part of the adding molecule goes to the carbon which has less number of hydrogen atom. Anti-Markovnikov rule says that negative part of the adding molecule goes to the carbon which has more hydrogen atoms. And please keep in mind that anti-Markovnikov rule is applicable only in case of HBr. I'll give you the reason why. Okay. So let's suppose you have this alkene which is propene. You have CH3, CH double bond, CH2. Okay, this is your propene. You are carrying out the addition of HBr, and that too in the presence of peroxide. Peroxide, you can take hydrogen peroxide H2O2. You can take sodium peroxide Na2O2. You can take benzoyl peroxide C6H5CO twice O2. So you can take any peroxide. So here, please keep in mind that if in your exam question is coming as CH3, CH double bond, CH2, I'm writing here CH double bond, CH2, and you have to carry out the addition of HBr only. Peroxide is not written. So here you will apply Markovnikov's rule. Here you will apply Markovnikov's rule. Markovnikov's rule. Because peroxide presence is not there. But here, because peroxide is written, and so we have to follow anti-Markovnikov's rule in this case. Anti-Markovnikov's rule. Okay. So according to anti-Markovnikov's rule, negative part of the adding molecule goes to the carbon which has more number of hydrogen atoms. Okay. So what you will get is CH3, CH2 single bond, CH2Br. This is gonna be your major product, and you have to make only major, not minor one. Getting my point? But if this is the case, then your product formed here would be CH3, CHBr, and CH3. First of all, tell me, is this part clear? But the point is that why? So anti-Markovnikov's rule is applied in case of peroxide. When peroxide presence is there, it is mandatory peroxide, because this portion was also there in class 11th, that this anti-Markovnikov's reaction or this rule, during its mechanism, free radical formation takes place, and that those free radical formation takes place only in presence of peroxide. Okay, so peroxide is important. That too, the addition of HBr is important, but the question is why? Why HF, HI, or HCl? We don't use these hydrogen halides in case of anti-Markovnikov rules. That's our next question. First of all, tell me if it is clear or not quickly. Quickly, everybody. So in presence of peroxide, the reaction takes place opposite to our rule. Above anti-Markovnikov rule is for HBr only. But the question is this: why peroxide effect is observed only in case of HBr and not with HF, HCl, HI? So let's discuss about it. These all are my hydrogen halides: HF, HCl, HBr, and my HI. See, peroxide effect, like during its mechanism, we use peroxide, and free radical formation takes place because of the presence of sunlight. Now, if I'll talk about all these hydrogen halides, मैंने ऐसे क्यों लिखा है? If I'll talk about all these hydrogen halides, so out of all these hydrogen halides, which halide has the strongest bond in it?
HF.
HF. So, because the mechanism takes place in the presence of sunlight, because of which free radical formation takes place, so sunlight won't be able to break the bonds of hydrogen fluoride or hydrogen chloride, because here the bond dissociation enthalpy is high. So I'm writing here that their bond dissociation enthalpy is high. High bond dissociation enthalpy. Okay, because they have high bond dissociation enthalpy, sunlight won't be able to break these bonds. So no free radicals in case of HF and HCl. So now we have two options. One is HBr and other is HI. Free radical formation will take place very easily in case of HI. So what will happen in case of HI? Your homolytic fission takes place. In homolytic fission, one electron will go here, one will go here. H radical and I radical will form. Now the I radicals so formed, it's not that in HI we just have one molecule, there are many and they will be forming free radicals. Those free radicals combine with each other quickly, very quickly, to form I2. And we don't have any radical available in case of HI. We don't have any free radical available in case of HI, because the iodine radicals so form, they undergo coupling reaction to form I2. When you don't have iodine radical, how it is going to attack at the alkene? Getting my point? So that is why we have only HBr. That's why we carry out the addition of HBr only in case of anti-Markovnikov's rule. Is this clear? Iodine radicals so form here in case of HI, they undergo coupling reaction to form I2. So free iodine radicals are not available. Is this clear? Clear, boss? Chalo. So that was about from alkenes, and in alkenes we have the next one, which is addition of halogens. So in from hydrocarbons we discussed about from alkenes how we prepare haloalkanes. In this we have the second part as addition of, we carried out the addition of hydrogen halide in the previous topic. Now we'll carry out the addition of halogens, like addition of Br2. So like let's suppose you have any alkene and you are carrying out the addition of halogen. Like here we use bromine commonly, because bromine is a brown colored gas. This is the color of bromine. I'm sure you can, why it is appearing red here? I'm sure it's appearing purple too. In my screen, it's appearing red. It's bromine has is a reddish brown colored gas. Okay, it is a reddish brown colored gas. Brown colored gas. So what we do, because it's a gas, the molecules, they will move here and there. So we dissolve it in CCl4, carbon tetrachloride. and we carry out its addition on any alkene. If we have any alkene and we'll carry out the addition of bromine, which is a brown colored gas, the color of bromine, like here, the color will discharge when we'll carry out its addition on any alkene. The color will not discharge when we'll carry out its addition on alkene. So what will happen over here? One bromine will attach here, one bromine will attach here. So you will get CH2Br, single bond CH2Br. This is your vicinal, because the two halogen atoms, they are attached in the vicinity of the adjacent carbon atom. So it will result into the formation of vicinal dihalide, vicinal dibromide. And the color of this compound is colorless. So that is why we say that if the color of bromine in CCl4 is discharging on addition on addition to any compound, then it confirms that the compound was unsaturated. This reaction is also used as a test for unsaturation. Let's suppose I'm giving you two compounds and I want to identify which one is unsaturated or which one is saturated. So you can perform this test. You can just add bromine and CCl4 to both the compounds. If color is gonna change, then the compound must be your alkene or alkyne. It can be alkyne as well. For that, we will do further tests, but that confirms unsaturation. Is this clear? Is this clear, all of you? Everybody? Okay, so addition of bromine in CCl4 to an alkene resulting in discharge of reddish brown color constitutes an important, this is an important method for detection of double bond in a molecule. Chalo. So next, so we discussed about preparation of alkyl halides from alkenes. Now we will talk about preparation of alkyl halides from your alkanes. So write down from alkanes. From hydrocarbons, you have the second part, which is from alkanes. So let's take the case of propane. Let's suppose you have propane, CH3, CH2, CH3. This is your propane. Now, of course, we want to convert it into haloalkane. So we'll carry out the addition of halogen here. We'll take chlorine. Reaction of any halogen on alkene takes place in the presence of sunlight. So we'll write sunlight. Light has packets of energy, so we can also write H nu, or you can simply write H, UV light, ultraviolet light. Now, how many products will form over here? Please listen to me very, very carefully. First of all, one hydrogen from here, and one Cl from here will remove, and you will get the product as CH3, CH2, CH2Cl. Now, the number of products formed in this case, in case of halogenation of alkanes, is equals to number of different hydrogens present in your compound. If I'll talk about this carbon and this carbon, they both carbon atoms are same and their hydrogen atoms are same. Yes or no? So one product we have already made. Now the second product which is possible is when we'll replace the hydrogen of this carbon with chlorine. So the second compound which will form over here would be CH3, CHCl and CH3. So these are the only two compounds which are possible. Again, I am repeating, in case of reaction of alkene with halogen in the presence of sunlight, first of all, this follows free radical mechanism. Mechanism you don't have to study, but here also in its mechanism, free radical formation takes place. And the number of products formed in this reaction is equals to number of different hydrogens present in your compound, present in your alkane. Here, the two carbon atoms, they have same, so of course their hydrogens are same. So one product we have made here, when one hydrogen is being replaced by chlorine. So this is one chloropropane. Second product will form because this carbon is different and of course its hydrogen would be different from the other two. So yes, second product I have formed over here. Is this clear? No, there is no major minor here. No major minor. All are forming in equal amount. Okay, so let's take the case of, I'll take more examples. Let's take the case of this butane. You have CH3, CH2, CH2, CH3. Here also, how many different, this carbon and this carbon, they both are same. So one product will form when you will replace one hydrogen of this with chlorine. So that's why you're getting one product here. Yes or no? Now these two carbon atoms are same. This is second from here, second from here. So their hydrogens would be same. So one product you will form when you will replace one hydrogen of this with chlorine. Then you're getting second product. Here chlorine will come. Okay? I'll give you one more example. But first note it down. Once done, please let me know. And please be quick. There are many more reactions which we have to cover. Done.
Ma'am, I have a doubt.
Yes, please ask.
In the first reaction,
Hmm.
how did the product be CH3, CH2, 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 and Cl and Cl? Why there's two Cl in that
अरे
compound?
अरे अरे प्रॉब्लम हो गई यहाँ पे actually the one who made this PPT this got shifted here this CL should be here problem है ठीक है
Yes, ma'am. Yeah, thank you.
चलो so let's take one more example let's suppose you have this CH3 CH3 CH2 and CH3 can anyone tell me how many products will form on chlorination of this in the presence of sunlight how many products will form all of you beta 4 products will form over here how 4 products will form first of all when we replace this hydrogen with Cl so you will get the product as CH3 CH CH3 CH2 and CH2 Cl second product when we will replace this hydrogen with chlorine because that's different so next product here would be CH3 CH CH3 then you have CHCl and then you have CH3 okay what is gonna be next of course this carbon is different from other carbon atoms so hydrogen would be different so next one when we'll replace one hydrogen from here so you'll get CH3 CH3 Cl here and then CH2 and CH3 now what is next now if I look at these two carbon atoms they are different from this carbon right the two are different from this carbon but the two are similar yes or no the two carbon atoms here are similar so of course their hydrogens would be similar so one product will form over here when you replace hydrogen from here or from here so you will get the fourth product as CH3 CH2 Cl and then CH2 CH3 is that clear chlorine is able to bond with every carbon yes and every product different product is forming how the two carbon atoms different from which carbon atom I'm not able to read your message completely let me scroll it down how the two carbon atoms different from the first one which carbon atoms the two because here there is a branching and there is no branching over here Zayed Sheikh here if you are selecting this chain you can see in on second carbon there is a CH3 and here on second carbon there is no CH3 Sheikh is that clear beta then in previous example only two products were formed In previous, what was previous example? Here, yes, two were forming here because the two are same. The two are same. ठीक है आर्यन?
Okay, ma'am, I understood. Yeah.
Chalo. So that was about preparation of haloalkanes from your alkanes. Now let's talk about the next reaction, which is your Finkelstein reaction. Finkelstein reaction, and this comes into the category of halogen exchange reactions. Now the two reactions which are remaining in the preparation of haloalkanes is Finkelstein reaction and Schwarz reaction. They're very important. Again, they are name reactions. We'll be using them in conversions. But what is Finkelstein reaction? First of all, this reaction is used for the preparation of iodoalkanes. And we call them as halogen. I'm writing here the third, I don't know which number it is, but they come under the category of halogen exchange reactions. Halogen exchange reactions. And in halogen exchange, we have two. One is Finkelstein, another is Schwarz. So what is a Finkelstein reaction? When we treat chloroalkane or bromoalkane with sodium iodide in the presence of acetone. So it's here, it's a general equation written. I'll give you the example. So Rx you are taking, X here can be chloro or bromo. Again, I'm saying in this reaction, the reactants can only be chloroalkane or bromoalkane. We'll be treating them with NaI, sodium iodide, in the presence of acetone. So what is going to happen? NaX will remove and Ri will form. Let's understand this with the help of an example. Let's suppose you are taking chloroethane, CH3, CH2, Cl. You are treating it with NaI, which is sodium iodide. Reaction takes place in the presence of acetone. Okay. So what is going to happen over here? NaCl is removing. And in place of Cl, iodine is coming. So can you see here that halogen exchange is taking place over here? Yes. So you will get iodoalkane. This reaction is only used for the preparation of iodoalkane and NaCl will form. Similarly, you can take bromoalkane as well, but only chloro and bromoalkanes you can take. So you can take CH3, CH2Br. You are treating it with sodium iodide and in the presence of acetone, and then NaBr will remove. NaBr will remove and you will get your iodoalkane. CH3, CH2, I plus NaBr. Okay. Now NaBr and NaCl, they are less soluble in acetone. Because they are less soluble in acetone, they can be easily precipitated. If they can be easily precipitated, we can remove them easily. And we can remove them, we can increase the yield of the product according to Lee-Chatelain principle, but that's more in detail. First of all, tell me, is this reaction clear to you or not? Halogen exchange is taking place. The reactants can only be chloroalkane or bromoalkane. You have to treat them with sodium iodide. Acetone presence is required. Why we are taking acetone? Because NaBr and NaCl, they are less soluble in acetone. So they can be easily precipitated. And we can get our iodoalkanes in more pure form. Okay? That is all about Finkelstein reaction. Now, what if we want to prepare fluoroalkanes? I don't want iodoalkane, I want to prepare fluoroalkane. For that, we have different name reaction, which is my Schwarz reaction. And there the exchange of halogen, that is chloroalkane and bromoalkane, takes place with fluorine. Here it was taking place with iodine. Exchange is taking place with iodine. There the exchange will take place with fluorine. Okay. So next reaction we have is our Schwarz reaction. So what you can write the general equation of Schwarz reaction as, you are taking haloalkane. Now sure, please keep in mind, halogen can be chlorine or bromine only. You will treat it with AgF, silver fluoride. So sure, what is going to happen? AgX will remove and fluorine will get connected with the alkyl group to form fluoroalkene. AgX will remove. Is that clear? So sure, in place of AgF, you can also use mercurous fluoride, Hg2F2, SbF3, which is antimony trifluoride, cobalt trifluoride. These can also be used. Let's suppose you have CH3, CH2, Cl, and you are treating it with Hg2 F2. Then what you will get? You will get your CH3, CH2F, and there would be removal of Hg2Cl2. Got it? This is Schwarz reaction. This is again, there is again a halogen exchange taking place, but this time with chlorine. This is called Schwarz reaction. Clear, beta? All the preparations. That's all about the preparation of haloalkanes. Now let's move towards the preparation of haloarenes, if it is clear. Noted, boss? Here again, you can take bromoalkene as well. Everybody noted? Enjoying reactions? Enjoying reactions? देखते हैं कितने बच्चे enjoy कर रहे हैं. How many of you are enjoying these reactions? Just curious. So Aryan, Sashi Kumar, they too are very active. What about others? 46 students are there. Fazila, Reshmi, Tanmay, Nuha, Darun, Sehel, Biju, Disha. I want to see if any other name, new name is popping up or not. Arbeen, Amira. जैद ने बोला अब तो मैम हो गया सीसी. ठीक है, चलो आगे. So now let's move towards the preparation of
Once again.
what?
Could you no, could you go to the free radical halogenation slide?
Free radical halogenation. This one.
Yeah. Wait, no, the next one.
Done.
The one after this.
Done.
No, the one after this.
Other one.
Yeah. Just 1 second.
Yeah. किसको सपना लगे तू, किसको महके हवा, किसकी
Okay, ma'am.
Done. Chalo.
Good, ma'am. Thank you.
Let's move towards the preparation of haloarenes. So here we have the first reaction, that is direct halogenation. So in case of haloarenes, we have how many reactions? 3 reactions. One is direct halogenation of aromatic ring, or it is also called electrophilic substitution reaction. So let's understand how we carry out this reaction. Direct halogenation of aromatic ring. So you will take your aromatic ring, that is, you can take benzene. You will carry out its reaction with chlorine, but the reaction does not take place in normal condition. Matlab, it will not take place in the presence of sunlight. It will take place only in dark. You have to, like, sunlight should not be there. So when we used to perform such reactions in our, when I was in college, so we used to keep the beaker in our lockers. We were provided lockers to keep our instruments so that light won't enter into the beaker. Okay. So chlorination you will carry out, and the reaction will take place. You can take FeCl3 or AlCl3 over here. They both are Lewis acids, and again they will help in the generation of the electrophile. Mechanism I will provide you. Okay. So condition is that there should be dark. Temperature you have to maintain as 310 to 320. Temperature, I guess this is the condition of pressure. 310 to 320 atm. Just a moment. I want to check. I'm getting confused. No, it's temperature you have to maintain. The reaction mixture should be heated to 310 to 320 atm. Okay. And then you will keep it in a dark room where sunlight should not be there. So what is going to happen here? This is, see, on benzene ring, each carbon atom is having hydrogen atom, right? Benzene has the formula C6H6, so every carbon atom is having hydrogen. So I'm showing this hydrogen because I want to show that how chlorine is going to attach. Now one hydrogen from here. Just a moment, guys. एक minute. ये क्या हो गया है? I think it's connected.
Powering off. Connect again soon.
Speaker is connected to my mother's phone, and she's gonna play something. Off करना पड़ा. हाँ जी. So hydrogen from here and Cl from here. So HCl will remove and chlorine is gonna attach over here. You will get chlorobenzene. Again, this is not a mechanism. Mechanism I'll give you. So you'll get chlorobenzene along with the removal of HCl. Okay. Similarly, if you want to carry out the reaction of bromine, you can also carry out the reaction with bromine in the presence of FeBr3, maintaining temperature of 310 to 328 why I'm saying it in Kelvin. So hydrogen from here, Br from here is gonna remove and you'll get bromobenzene. Okay. Plus HBr. Done. Noted. Now I'll tell you what is the purpose of I will have to enjoy varna fail. सही बात है. There is no other option. Beta, once done, please let me know. Done. So now let me tell you what is the purpose of FeCl3 and how it is a electrophilic substitution reaction. How electrophile is attacking over the benzene ring. That's what I'm gonna explain. So what you are taking you are carrying out chlorination in the presence of FeCl3 and or you can take AlCl3 because they both are Lewis acids and Lewis acids are electron deficient species. So I'm writing mechanism here. Mechanism. So you are taking chlorine, ClCl, they link with each other, and you are taking FeCl3, which is a Lewis acid, right, beta? Now, Lewis acids, they are electron deficient species, they want electrons. So, what is going to happen? In the presence of this FeCl3, the chlorine, this bond is going to break in such a fashion that the shared pair of electron will move towards one of the atoms. Why it is moving towards one of the atom, moving towards chlorine? Because we have taken FeCl3. In its presence, only the bond will get cleaved heterolytically. There is a heterolytic cleavage going on, right? So it will only take place in the presence of FeCl3. So why is it happening? Because FeCl3 wants electron. So FeCl3 will combine with Cl minus to form FeCl4 minus. FeCl4 minus and Cl positive, which is an electrophile. What are electrophiles? Electrophiles are electron deficient species. Nucleophiles are electron rich species. I'm sure you are aware about electrophile and nucleophile. So there is a generation, this electrophile Cl positive is only getting generated in the presence of FeCl3. Otherwise, it won't generate because the two chlorine atoms, they have equal electronegativity. Okay. Now this Cl positive ion so generated, this is gonna attack on the benzene ring. So how it is gonna attack? So this is your benzene ring and this is your Cl positive. If let's suppose if it has to attack over the benzene ring and in benzene ring there is a delocalization of pi electrons. Let's suppose the pi electrons are moving here. This carbon would get negative charge. If it would get negative charge, Cl positive will attack here. So what you will get is the bond, this bond is here, this bond is here. Because the pi electrons are shifting here, this carbon would get negative charge, but there would be a positive charge on this carbon atoms here, and on this carbon atom, Cl minus is gonna come and attack. I'm showing here. Here. So what you will get is your Cl will attack over here. Is there any problem till now? Is there any problem till now? Any problem? And this is gonna be resonance stabilized. I'm sure you know how to draw the resonance. First of all, tell me if there is any doubt till now, then I'll move ahead. Any doubt, any problem? Can you explain again? Okay. From where? From the first step. This is your first step. This is your second step. First or second? Second. Okay. So the electrophile so generated is gonna attack on the benzene ring. In benzene ring, there are double bonds, three double bonds, and there is a delocalization of electron which take place. Pi electrons can shift here or here. Let's suppose they are shifting here. So this carbon would get negative charge. If it is having negative, positive then will attack over the negative one only. So that is how chlorine is getting linked, and this carbon would get positive charge because the pi electrons they got shifted here. Positive charge. ठीक है आसिफ? Now this would be resonance stabilized. How it would be resonance stabilized? I'm sure you guys know how to draw resonance structure. There are pi electrons here, they can move here. If they can move here, when we draw resonance structure, we put double-sided arrow. This is your benzene ring. Now this carbon would get positive. Negative positive here will make the bond here and Cl. Okay. Now in the next, see I'm showing the resonance structures to you now, that how it is going to be resonance stabilized. Okay. Now in the next one, what is going to happen? The pi electrons they will move here. This carbon has positive charge, so this should be negative. The pi electrons they will move here. So if they will move here, negative positive will make the bond. This would get positive charge. So that is how it is resonance stabilized. Is this clear, beta? Resonance stabilized. But we have to make the final product. Now here in this structure, what is going to happen next? How it will form the final product? At this carbon atom, there is a hydrogen atom also present, because in benzene ring at each carbon atom there is a hydrogen. So there would be removal of the proton. So H plus will leave from here. The electrons they will shift here. This carbon would get negative. This would get this is already positive. Will make a double bond. Negative positive will make a bond. Cl. H plus so generated here. The H plus so generated plus I'm writing plus H plus. Now this will combine with FeCl4 minus to regenerate FeCl3 and HCl. This is the mechanism. Again, these all are showing the resonance stabilized, like how this is the positive charge in the benzene, how this is resonance stabilized. ज़्यादा complicated हो गया लगता है. हाँ? Beta, have you understood? I'm sure it's not complicated for you. Quickly tell me, we have two more reactions which we have to cover. Send me a reaction. Next. कोई बात नहीं, just try writing it once after your class. Once or twice, like one time or two time. It's okay. थोड़ा तो डर आ गया है लगता है. Just try writing the mechanism after the class.
Ma'am, it's supposed to be a plus after HCl, right?
Supposed to be
A plus. A
after,
plus sign.
Yes, this is a plus sign. Plus FeC.
No, after that. Like to the right side.
This is HCl, this is plus, this is FeCl3, and this is the removal of H plus which is taking place over here.
So that forms this.
I'm writing plus H plus. Okay. Okay.
Yes, ma'am.
Beta noted. There is, you can note down removal of H plus. This mechanism is not there in NCERT. It's not there, I guess, in NCERT. It's not there in NCERT. So if it's not there in NCERT, it is not gonna be asked in your board exams. That's so for sure. Your paper won't come out of NCERT. Chalo. So noted. Now let's move towards the next question. Next preparation. That is Sandwich reaction. From amines by Sandwich reaction. So let's talk about what is Sandwich reaction. Please listen to me very, very carefully. In Sandwich reaction, what we do, we treat aniline with NaNO2 and HCl. First of all, NaNO2 and HCl, they will react. We are gonna take this mixture and gonna treat this with aniline. So NaNO2 and HCl, they will react with each other to form what? NaCl and HNO2. Yes, NaCl and HNO2. Okay. Now the HNO2 so formed here in a Sandwich reaction. There is a first step, that is you take aniline. You have to take aniline, which is NH2 present on benzene ring. This is aniline, and you are treating it with NaNO2 and HCl mixture. NaNO2 and HCl will give HNO2. So I'm writing here HNO2 directly. You can also write NaNO2 and HCl and HCl. So here the temperature which you have to maintain, like here the temperature should be ice cold, that is 0 to 5 degrees Celsius temperature you have to maintain. Now what is gonna happen? Benzene diazonium salt is gonna form. So what is benzene diazonium salt? How you will make it? Please listen to me. I'm telling you the way how you should write the product. So N2Cl present on benzene ring. N2Cl. Then what is remaining? N2Cl is there. What is remaining is your hydrogen and oxygen. That means your water will remove H2O. In case you want to balance it, how many water molecules are removing? 2. Okay. Now in this is not Sandwich reaction is not complete till now. So in this step, what we have done, we have treated aniline with NaNO2 and HCl mixture, and it is forming benzene diazonium chloride. What is the name of this compound? Let me draw its structure. It will be easy for you. This is benzene, and on benzene you have N double bond NCl. This group beta, this is called diazo group. This one, diazo group. Okay. So how we will write its name? Benzene diazonium chloride. Okay. Benzene diazonium chloride. Beta, is that clear? Benzene diazonium chloride, and that's how we write it as C6H5N2Cl. We can also write it as C6H5N2Cl, which is benzene diazonium chloride. Okay. Now, because in this step, when we treated aniline with NaNO2 and HCl mixture, maintaining a temperature of 0 to 5 degrees Celsius, there is a formation of there is an introduction of diazonium group onto benzene ring. So that's why this step is called diazotization. So I'm writing here, this step is called introduction of this diazonium group onto this benzene ring is called diazotization. Is this clear? Diazotization, because there is a diazonium group getting introduced onto the benzene ring. Now reaction is not complete. Now in Sandwich reaction, what we do, we treat benzene diazonium chloride with the with cuprous chloride in the presence of its corresponding halogen acid. Now what is that? Let's understand. So this is your benzene diazonium chloride N2Cl. You will treat it with the cuprous chloride, which is Cu2Cl2, in the presence of its corresponding halogen acid. If you are taking Cu2Cl2, you have to take HCl. If you are taking Cu2Br2, you have to take HBr. So what will form in Sandwich reaction? Please keep in mind that N2 will always remove as a side product. Okay. So what you will get is your N2 group will remove, and there would be an introduction of this halogen, whatever you are taking, onto the benzene ring. So you will get chlorobenzene. let's suppose you are treating this benzene diazoxide chloride with cuprous bromide Cu2Br2 in the presence of HBr. Then in this case, Br is gonna introduce onto benzene ring. Okay? So bromine is gonna introduce onto benzene ring, and there would be removal of nitrogen gas. So nitrogen gas would always be the byproduct. Is that clear? So let me again tell you, if let's suppose in your exam, they're asking you what, write a short note on, in your board exam I'm talking about, because those questions are subjective. Write a short note on Steinway reaction. So you'll not write only this one. You have to start from here. Okay? You will also write this step. Clear? You'll first write this diazotization step, and then you will write any of the reaction, whatever you want to write. Boss, is that clear? Are the byproducts? Yes, they are important. They are not important in case of conversions. When there are conversions which are asked in exams. Byproducts are important in all the reactions except your conversions. In conversions, you don't need to write byproducts. Rest everywhere you have to write byproduct. Is that clear? So, beta, is this clear? Now, let's suppose you have to make iodobenzene. If you want to make iodobenzene, conversions meaning, let me just take 2 to 3 sessions of organic, then I'll explain what is conversion. Where you have to, like, they can ask you direct question, convert aniline to chlorobenzene. Convert aniline to chlorobenzene. So there you have to decide which reaction I should use to carry out this conversion. They are called conversions. They are definitely gonna be there in your exam. Chalo. Now what if you want to make iodobenzene? So in case of iodobenzene, you just treat your benzene diazonium chloride with Ki, and there you don't need any cuprous iodide or halogen acid. No. So you can note down this reaction. This is your benzene diazonium chloride. You just treat it with Ki, and N2 will remove and iodine will introduce. So replacement of diazonium group by iodine does not require the presence of cuprous halide and is done simply by shaking diazonium salt with potassium iodide. Please note down this reaction. Please be quick. We have less time. We have to cover one more reaction. Acha, nahi, we are done. We are done. Ho gaya. Preparations are over. But I think one more reaction was also there. Gattermann reaction was also there. Please note it down. Let me tell you. It's not there in the slide, but let me tell you. There is one more reaction which is called Gattermann reaction. Done. Coming to Gattermann now. I forgot to
Sir,
ask.
ma'am, what happened to the halogens over there? What happens to the halogen in the with the N2?
Halogen can be chlorine. It would be chlorine only because we are taking NaNO2 and HCl.
Yeah, where does it go, ma'am? It's not written on the other side.
So that byproduct you don't need to show. Okay? You just
Okay,
have to
ma'am,
write
understood.
N2 will remove and add that simple. Because we are not studying any mechanism. Chalo. So now let's talk about Gattermann reaction. Gattermann reaction, it is a modification of Sandmeyer reaction, beta. Gattermann reaction. You can write it down as modification of Sandmeyer. Modification of Sandmeyer. And how it is a modification of Sandmeyer? So what you have to do here, you have to take benzene diazonium chloride only, N2Cl. In Sandmeyer, you are treating your benzene diazonium chloride with cuprous chloride and corresponding halogen acid. But in Gattermann reaction, you don't need to take copper chloride. No, just simple copper and halogen acid. Let's suppose you want to carry out the introduction of Cl. You will take HCl. If you want to carry out the introduction of bromine, you will take HBr. So here you don't need to take cuprous halide, cuprous chloride or bromide. So again, so here your byproduct would be C6H5 Cl plus there would be removal of N2, and here we are along with removal of N2. Okay. In case
Ma'am, another doubt.
you want to,
Another doubt, ma'am.
Hanji.
Should it be like N2Br in order to put HBr and change it to Br? Like over here in this example, with disonium, benzene disonium chloride, you added HBr with Cu. So is it like you need benzene disonium bromide instead of like chloride? Is it
No,
compulsory to keep it like that?
again the step is same. The first step is same. You have to treat your aniline with NaNO2 and HCl, so it would be chloride only.
Oh, okay, ma'am, fine.
So, in case you want to prepare iodobenzene, so you just treat it with Ki, warm it with Ki, then you will get your iodobenzene. Okay? Ki, warm it, and then you will get your iodobenzene. Is that clear, beta? That's all about Gatterman reaction. So now we are done with the preparation part. So in next class, we will start with the physical properties. So what I want now is just that I added 4 questions. With the help of those 4 questions, we'll be able to revise whatever we have studied. So I won't be giving you poll. You can just quickly give the answer in the chat box. If you have noted this down, please let me know. We'll move towards questions. Balshiman is not there in your
Ma'am,
syllabus, not in NCERT.
ma'am, for 1 second, could you show the previous slide?
This
Yeah, ma'am. Thank you.
done, beta? Chalo.
Yeah,
So
done.
here is the question. Please give the answer in the chat box because we don't have that much time. Getman is in NCERT. Yes. I guess it's there in NCERT. I don't know. How you can check it. So Haloarenes at the end of somewhere. It's always N2, right? Great. Next. What is this reaction called? Treating chloroalkane with NaI in the presence of diacetone. This reaction is called? No, not Swartz. In Swartz, fluoroalkanes form. But here iodoalkane is forming. So this is Finkelstein. Very good. Next question. Methyl bromide reacts with AgF to give methyl chloride. You are getting fluoroalkane. So this is Swartz reaction. Very good. Next. Bus done. Next we have the physical properties, but those we won't be able to cover. Acha, one more question. Ek aur, last. One last. Reaction of primary alcohol with which of the following gives purely a haloalkane? In which case you will get pure haloalkane? With phosphorus pentachloride or thionyl chloride? Of course, second, that is thionyl chloride. Okay. So that's it. I wanted to cover physical properties too, but time is not there, so we'll be doing them in next class. So in preparation, we discussed about preparation part, and in preparation we discussed about, first I'm writing a quick summary over here. First we started the preparation from alcohols, right beta? Now what is your homework is that you should write on your own. You have studied this in the class. You should take your rough notebook. You should write on your own from alcohol what all reactions were there, in alkanes what all reactions were there, from alkenes and all. So that's your homework. So first we prepared from alcohol, then what was second? From hydrocarbons, right? In hydrocarbons we prepared from alkene and from alkane. So next one was from hydrocarbons, in which there were 2 parts, alkene and from alkene. That's how you should link. You should write in your copies. Yeah. Chlorobenzene we won't be able to prepare. The reaction is violent. Chalo. So and for that we have different condition in case you want to prepare, but that's not there in NCERT. What I was telling, that is next. we studied about Finkelstein reaction, halogen exchange. Okay. So what is your homework, guys? You'll be able to learn these reactions only when you will practice writing like this. Okay. So would you be doing this homework after the class? Hanji. Pakka? See you in next class. Bye bye. Take care. Good night. Go enjoy your next class. Having which subject is it? How, ma'am, like how do we practice? For practice, I'll give you question, but first you should learn. You should write these reactions in your rough notebook, in order wise, in the order which I have, the way I explained you, like that. For practice, I'll give you questions. Which subject is next? Next class, zoology. चलो फिर जाओ enjoy करो. Bye bye. बाय बाय. पहले लेक्चर में ही रोना आ गया. अरे रो कौन रहा है भाई? नबीहा. अच्छा रोने वाला लेक्चर तो नहीं था यार ये. हाँ जी नबीहा, दिस वाज योर फर्स्ट लेक्चर. देखो रोना नहीं है, मेरे को रुला दो, खुद मत रो. कोई बात नहीं, जस्ट गो एंड प्रैक्टिस दीज रिएक्शंस. ठीक है, बढ़िया था. ठीक है, बाय. टाटा. गुड नाइट.